Have you ever wondered what a warship from the future would look like if it sailed into today's oceans? Not a science fiction movie prop, not an artist's sketch, but a real steel-hulled destroyer, larger than a World War II battleship, yet designed to vanish from radar as if it were a small fishing boat. Meet the USS Zumwalt, DDG-1000, America's most advanced, most expensive, and most controversial destroyer ever built. With its sharp, wave-piercing tumble-home hull, angular stealth design, and futuristic technology, the Zumwalt was supposed to redefine naval warfare. Instead, it became both a symbol of ambition and a cautionary tale about pushing technology too far, too fast. If you love exploring the hidden stories behind the world's most powerful war machines, make sure to subscribe right now and hit the like button to support our work, bringing you the inside look at the weapons shaping tomorrow's battles. The story of the Zumwalt begins not in the shipyard, but in the strategic mindset of the US Navy at the end of the Cold War. In the early 1990s, American admirals were obsessed with one question: how do you build a warship capable of dominating literal waters, the shallow coastal zones where future conflicts were expected to erupt? Conventional destroyers like the Arleigh Burke class were powerful, but their design dated back to the 1980s. The Navy wanted something radically different. Something that could sneak close to hostile shores, bombard land targets with devastating precision, and survive inside an enemy's defensive bubble. Thus was born the DD-21 program, later renamed DDG-1000. It promised a revolution in naval warfare, stealth on the seas, overwhelming firepower, and a platform ready for the 21st century. What makes the Zumwalt instantly recognizable is its shape. Instead of the outward-sloping hulls of traditional warships, Zumwalt features a tumble-home design. The sides of the ship actually slope inward as they rise. This radical geometry dramatically reduces radar cross-section. On enemy screens, a 610-foot warship can appear no larger than a small patrol craft. Its superstructure, made from composite materials, hides antennas, radars, and weapons behind flat panels. Even the massive gun barrels were designed with stealth in mind. From the air, Zumwalt looks less like a warship and more like a jagged wedge cutting through the ocean. The Navy claimed this would allow Zumwalt to get closer to enemy shores undetected, launch strikes, and retreat before anyone realized what happened. But stealth was only part of the vision. The Zumwalt's integrated power system, IPS, was revolutionary. Instead of separate generators for propulsion and weapons, the destroyer produces a staggering 78 megawatts of electrical power, more than enough to light up a medium-sized American city. Why? Because the Navy wasn't just thinking about today's weapons. They dreamed of tomorrow's arsenal: electromagnetic railguns, directed energy lasers, advanced radar systems. Zumwalt was meant to be the first ship that could power them all. In many ways, it was less a destroyer and more a technology testbed disguised as a warship. But revolutions don't come cheap. The original plan called for 32 Zumwalts. As cost ballooned, the number was slashed to 24, then 7, and finally just 3. Each of those 3 ships, USS Zumwalt, USS Michael Mansour, and USS Lyndon B. Johnson, carries a jaw-dropping price tag of nearly $8 billion when research and development are included. To critics, it was a disaster. The Navy spent billions for 3 ships that couldn't even fire their advanced guns because the specially designed ammunition cost nearly $1 million per round. To supporters, it was a bold step into the future, an investment in technologies that will eventually define naval warfare. And that is where our story truly begins. The Zumwalt is not just a warship, it is a floating paradox. A ship born from ambition, weighed down by cost, yet still carrying the seeds of tomorrow's weapons. In the next chapter, we'll take you inside the shipyard where this futuristic destroyer took shape, revealing the engineering marvels, ready and painful compromises that defined its construction. But before we continue, we want to hear from you. Do you think the Zumwalt was a mistake or a necessary leap forward? Tell us in the comments. And don't forget, hit that subscribe button so you won't miss part 2 of this incredible story. It's one thing to sketch a warship of the future on paper. It's another to actually build it. And that's where the Zumwalt story becomes even more fascinating. because creating this destroyer was as much a battle as any the Navy will ever fight at sea. Imagine a shipyard facing an impossible mission. Assemble the largest and most complex destroyer in U.S. history, using technologies that had never been tested at sea, with no blueprint from the past to guide the way. This was the challenge for Bath Iron Works in Maine, the birthplace of Zumwalt. Before we dive in, if you enjoy deep dive stories about how these engineering giants come to life, make sure to like this video. It tells us you want more military history and technology breakdowns, just like this one. At 610 feet long and 81 feet wide, Zumwalt is almost as large as a World War II cruiser. Yet the way her hull came together broke every rule of traditional shipbuilding. Instead of the familiar outward-sloping sides of Arleigh Burke destroyers, Zumwalt's inward-sloping tumble-home hull forced engineers to invent new methods of construction. Thousands of steel plates had to be cut with microscopic precision so the ship's stealth angles lined up perfectly. Even the smallest misalignment could compromise radar reduction. Every step was slow, deliberate, and painful. Traditional shipwrights compared it to teaching master carpenters to suddenly work with glass. One wrong move and the entire project could shatter. The Navy called it modular construction. Massive sections of the ship, weighing thousands of tons each, were built separately, then joined together like Lego blocks inside the dry dock. But this was no children's toy. Each block contained advanced wiring, sensors, and electronic guts that had to fit together flawlessly when lowered into place. One wrong weld could cost months of delays and millions of dollars. The dry dock at Bath Iron Works became a stage for a slow-motion industrial ballet. Cranes moving house-sized steel modules, welders sealing futuristic joints, engineers triple-checking tolerances. Even as the hull took shape, the Navy had already selected the first officers and sailors who would crew Zumwalt. They trained for years before ever setting foot aboard, learning systems no warship had ever used before. The ship's bridge looked more like a spaceship than a destroyer. Touchscreen displays replaced traditional gauges. Control systems integrated navigation, engineering, and combat into one seamless digital network. Sailors nicknamed it the Starship Bridge. And unlike the 300-plus crew of a Burke destroyer, Zumwalt required barely 175 sailors, a historic reduction in manpower achieved through automation. For the Navy, this meant fewer lives at risk in combat. For the crew, it meant every sailor carried more responsibility than ever before. On a cold October morning in 2013, the world finally saw what had been hidden inside the shipyard walls. The massive dry dock flooded, tugboats inched forward, and USS Zumwalt, DDG 1000, touched water for the very first time. Witnesses described the moment as surreal. A warship with the lines of a futuristic sculpture slid silently into the river Kennebec. From the shore, it looked less like a destroyer and more like an alien craft. A wedge of steel and secrecy breaking into the surface of the water. It was supposed to be a triumph. And in many ways, it was. But as the ship floated free, reality began to set in. Building the Zumwalt had been only half the challenge. The other half would come when the Navy tried to actually use her. In the next chapter, we'll take you on board Zumwalt's early sea trials, where engines failed, electronics glitched, and the Navy learned what it really meant to bring a warship of the future into today's fleet. But before we go, don't miss out. Subscribe to the channel now and join our growing community of viewers who love military history and technology. And let us know in the comments, would you volunteer to serve on a ship like Zumwalt with systems no sailor has ever touched before? Launching a ship is one thing, proving she can fight is another. And when the USS Zumwalt finally left the river and sailed into open waters, the Navy discovered that the future doesn't always arrive without turbulence. From the very beginning, Zumwalt's sea trials were a trial by fire, exposing just how difficult it is to take a warship built on untested ideas and turn it into an operational destroyer. If you want more stories about the moments when billion-dollar projects succeed or fail, like in dramatic fashion, hit that like button now. It helps us keep producing content you love, and it tells us you want more frontline history and tech deep dives. In December 2015, Zumwalt sailed down the Kennebec River into the Atlantic for her first set of trials. Reporters and locals watched as the massive angular warship glided past, a futuristic blade against the gray main sky. Inside, engineers and sailors braced themselves. Every system, every circuit, every turbine had to be tested. The integrated power system, capable of producing 78 megawatts of electricity, hummed to life. Radar systems searched the horizon. Computerized controls ran through endless diagnostics. At first, things seemed promising. The ship handled smoothly, riding waves like no other destroyer. Her stealth profile baffled sensors, confirming the Navy's promise. On radar, she looked like a small fishing boat, not a billion-dollar warship. But then the problems began. Zumwalt's complex power system, the very heart of her futuristic design, began showing flaws. Generators tripped offline under load. Software glitches froze vital controls. Even basic functions like propulsion weren't immune. The most embarrassing moment came in November 2016, just weeks after commissioning, when Zumwalt suffered a major mechanical breakdown while crossing the Panama Canal. Both propulsion motors failed due to seawater contamination in the lubrication system. Tugboats had to tow the Navy's $4 billion flagship through one of the busiest waterways on Earth. For critics, it was proof the Zumwalt was a white elephant. Too complex, too fragile, too expensive. For supporters, it was part of the painful process of bringing revolutionary technology to life. But the propulsion issues weren't the only setback. Zumwalt's Advanced Gun System, AGS, two massive 155mm cannons mounted forward, was supposed to deliver long-range precision fire, bombarding targets up to 80 miles inland with GPS-guided shells. The catch? Each round cost nearly $1 million. That made the guns essentially useless. The Navy canceled ammunition procurement, leaving Zumwalt with two giant guns that could not be fired in combat. A destroyer built to dominate coastal battles suddenly found itself without its primary weapon. Meanwhile, the reduced crew of just 175 sailors discovered that operating a futuristic warship meant living under constant pressure. Automation was supposed to replace manpower, but systems still needed human oversight. Sailors found themselves stretched thin, each person carrying roles that once took multiple specialists. For the officers, it was like captaining both a ship and a prototype at the same time. Every failure had to be logged, studied, and corrected. Every voyage turned into both a mission and an experiment. Yet even through these setbacks, Zumwalt proved valuable. The Navy began reframing her role, not as a traditional destroyer, but as a technology testbed for the fleet of the future. Her massive power system, though temperamental, could one day support electromagnetic railguns or high-energy lasers. Her stealth design still baffled sensors, and her digital control systems gave the Navy data it could never have collected from older ships. The Zumwalt, once envisioned as the backbone of a new class of destroyers, was now evolving into something else: a laboratory at sea. In our final chapter, we'll reveal how the Zumwalt is being reinvented for the Navy of tomorrow, from new missile systems to possible laser weapons, and why, despite all her failures, she may still hold the key to America's future at sea. Before we continue, make sure you're subscribed with the bell turned on, because in the next episode, we'll show you how a troubled destroyer could become the cornerstone of naval warfare in the 21st century. A warship is more than steel, engines, and weapons. It is an idea, a vision of how nations fight and win at sea. And while the USS Zumwalt's journey has been marked by setbacks, the Navy is not finished with her yet. In fact, the story of Zumwalt may just be beginning. What do you do with the most advanced destroyer ever built when its original mission fails? You reinvent it. If you followed Zumwalt's story this far, don't forget to subscribe now and join our community of viewers fascinated by the rise and fall and rebirth of the Navy's most ambitious warship. With the advanced gun system abandoned, the Navy faced a dilemma. Billions invested in ships with weapons that couldn't be used. The solution was radical: refit Zumwalt into a missile-focused strike platform. Instead of long-range artillery, the destroyer would carry the Navy's most advanced missiles, including the conventional prompt strike hypersonic weapon. designed to hit targets anywhere on Earth in under an hour. For Zumwalt, this meant cutting into her sleek hull to install new vertical launch systems capable of handling weapons never before deployed at sea. A ship once built to bombard coastlines would now become a hunter of high-value targets deep inland. But the Navy hasn't given up on Zumwalt's original promise, a ship designed to wield tomorrow's arsenal. Her integrated power system still generates 78 megawatts of electricity, enough to power railguns or high-energy lasers. In a world where drones swarm the skies and hypersonic missiles scream toward fleets, the ability to field directed energy weapons could decide future battles. And no warship is better suited to host those systems than Zumwalt. Imagine a stealth destroyer firing a laser beam to slice drones out of the sky, or a railgun hurling a projectile at 7 times the speed of sound. These are not fantasies, they are the technologies Zumwalt was built to test. For the sailors who crew her, Zumwalt is more than an experiment. She is a challenge, proof that naval warfare is evolving faster than ever before. Though only 3 Zumwalts exist, their presence sends a message. When allies see her angular silhouette, they see America's willingness to gamble on the future. When adversaries track her radar profile, they are reminded that U.S. naval innovation is not finished. Yes, Zumwalt represents risk. Yes, she carries the scars of failure, but she also embodies a truth. If you want to dominate the seas of tomorrow, you cannot rely solely on the weapons of yesterday. Will Zumwalt be remembered as a failure, or as the prototype that paved the way for the Navy's next generation of warships? The answer may not be clear for decades. What is clear is that she forced the Navy to confront the challenges of stealth at sea, automation, and next-generation power systems. She proved that radical ideas can be built, even if they stumble on the path to success. As one admiral put it, the Zumwalt class may not have delivered what we planned, but it will deliver what we learn. And sometimes, in warfare, the lessons are as valuable as the weapons themselves. The USS Zumwalt may not fight the battles she was designed for, but in her steel frame lies the blueprint for the future of naval combat. What do you think? Is Zumwalt a failed dream or the first step into a new era of war at sea? Let us know in the comments. And if you've enjoyed this journey through the rise, fall, and rebirth of America's stealth destroyer, like this video, share it with friends, and subscribe so you don't miss our next deep dive into the world's most powerful military machines. Because the sea is changing, and the future is already here.